Good afternoon, or good morning, or good evening, everyone. This is Jussi Siltanen from NAPA speaking. Welcome to the NAPA webinar on how to monitor vulnerability and survivability of an intact ship as an introduction to NAPA Emergency Computer. I see that we have still a few people joining, but let's start the webinar. Our duration of the webinar is going to be approximately 60 minutes, probably a little bit under that. It depends a little bit on the questions that we will have. Regarding the questions, so there is a chat channel in this webinar tool. So please feel free to type your question there, and we will address the questions in the end of this webinar. So together with me, I have my colleague Alex Bashkoff. Alex is one of our technical consultants, and Alex is based in our Fort Lauderdale office. Hi, Alex. And then Madalina Oprea. Madalina is also working as a technical consultant, and she's based in our office in Galați in Romania. Hi, Madalina. And then myself, Jussi Siltanen, I'm responsible of the product management in the NAPA Safety Solution business. Now, regarding the agenda of today's webinar, so we will be going through an introduction to NAPA Emergency Computer, and then we are also going to have a short training on the main features of NAPA Emergency Computer. And then in the end, so we'll have the opportunity to answer to some of your questions that you may have during this webinar. Before, however, going on to some of the subjects and present you a little bit NAPA, I would probably like to know a little bit that who is online. So I'm going to start a poll, and you should be able to view that in the webinar tool. So now, if you will just take a couple of seconds and answer to us that what is your role in regards to what you might be doing in the shipping industry. I'll be coming back to the results, but let's first look a little bit about NAPA in a few words. The company NAPA, based here in Helsinki in Finland. So the word NAPA comes from Naval Architectural Package. We are one of the world's leading software solution, service and data analysis provider for ship design and ship operations. Our company is divided into three solution areas. First of all, really the NAPA original solution, which is the NAPA design, which has the solution for contract design and statutory compliance of hull form and performance. We also have the solutions for structural design as well. The solutions which you might know by name are NAPA Naval Architecture and NAPA Steel. Then for the whole fleet and the shipping companies, so we have solutions which are handling ship management from the point of view of operations optimization. And there you will have solutions such as the NAPA Fleet Intelligence, NAPA Voyage Optimization, and the Class NK NAPA Green solution. And then on board the ship, so we have the NAPA Safety Solutions, which have solutions integrated to the ship's different operations and functions on board in order to increase the safety, predictability, and traceability on board. And there are solutions such as the emergency computer, which we will be presenting to you today, and then the loading computer, as well as NAPA logbook, or electronic logbook solution. Now, a little bit about NAPA in numbers. We are a 30 years old company, and our experience, however, goes much longer than that. As said to you, so our headquarters are in Helsinki, Finland, but we have offices in 10 countries. Our turnover last year was almost 26 million euros. Some interesting facts is that approximately 95% of the new builds, yearly built, are done so by NAPA customers. There is 190 of us working at NAPA, and the different NAPA applications, so which I was describing to you in the previous slide. So we have approximately 12,000 active users for those applications. Now, before going on to the actual subject of NAPA Emergency Computer and increased safety at seas, so I'm just looking at about the results of the first poll. So we have now, among the attendants, 18% of the people are officers on board, 37% of the people are shoreside support people, and then 43% are working in other type of functions. Now, there is another question that I would like to ask from our audience, and you will have a second poll here now coming up, and this is about your knowledge of the NAPA products on board. So just would like to ask you if you have been previously using NAPA loading computer, or if you have been using both NAPA loading computer and NAPA emergency computer, or if you haven't been so far using the NAPA solutions on board. I'll come back to the results of these questions in a few minutes. Before that, so let's talk a little bit about safety at seas, which is really the core topic of NAPA Emergency Computer. So throughout the history, the importance of the life at seas is something that we have seen all the time, that it has to be increased. This is, of course, something that we remember, especially after some events that might happen at sea, and clearly there is. We can see the results of the increased safety at sea. So we have less and less major emergencies at seas, and less, of course, life of passengers and life of crews are under threat at seas. Especially the international cruise shipping companies have invested a lot in safety, and they have been requiring shipyards to provide different kind of solutions in order to increase the safety, be it the general safety on board, for example, fire safety, or then floating safety, which we are going to address today with NAPA Emergency Computer. However, we have to remember here as well, as the size of the ships is increasing, so the cruise liners become more and more complex. They have several technical safety systems, and people have to be able to use them and work with those quite effectively. So they need to be integrated into the other solutions and operations on board in order to have this comprehensive safety solution. And that's what we are going to show you also with the different solutions that NAPA is offering. So how is safety achieved? First of all, we have to see at all the proactive measures of safe operations at seas. From the point of view of the NAPA solutions, this means that the loading and documenting of the loading according to the rules has to be done safely. For that, we have the loading computer, the logbook, the checklists, and the status board as well, as just to mention a few solutions on board. But then also, during the operations, we have to know at what kind of risk level we are in terms of safety, and therefore, we have the vulnerability monitoring of the NAPA Emergency Computer. Now, in case of incident, so it's quite crucial to react as soon as possible with different kind of decision support tools. And there, the NAPA Emergency Computer will assist as well with different kind of functions, such as the survivability assessment, but also advisory cards, which are giving counteraction guidance, and then also support in terms of decision about if the ship should be evacuated or if there is a realistic possibility of safe return to port. Now, a little bit about the NAPA Emergency Computer, and I'm soon going to leave the screen to my colleagues to explain a little bit more. But basically, we are going to cover the three main functions of the NAPA Emergency Computer. First of all, this vulnerability monitoring, which is more or less the level or the risk level that you are taking when navigating at seas. Then the survivability assessment in case of damage, and then the advisory cards serving as decision support for managing in different kind of emergency situations. Now, let's have a look about the results of the second poll that I had for you. So it looks like at least 1/4, so 25% of the people, you have been using NAPA loading computer, just NAPA loading computer. Then almost 20% have been using NAPA loading computer and NAPA emergency computer. And then approximately 60% of the audience has not yet been using NAPA onboard solutions. So I hope that we will be able to give you some new information about the NAPA products here. Now, as said, so we are going to go a little bit deeper into the NAPA Emergency Computer. And I'm now going to leave the floor or the screen to Alex. So let's just switch this off. And Alex, the screen is yours.
Thank you, Jussi. First, I will go over the vulnerability module used in the NAPA Emergency Computer software. Vulnerability monitoring increases awareness of the ship's level of safety by providing information at a glance to the officers on board. The software uses a vulnerability level to indicate the level of safety, where a low green level means the ship is less vulnerable or considered operating safely, and a high red level means the ship is more vulnerable or more at risk in the case of damage. The vulnerability level is calculated based on three components. First, the number of compartments which could flood due to open watertight doors, as indicated in the chart. Second, the navigational mode, which could be port, sea, or sea with risk, which, for example, could be maneuvering or a tight sea passage. Lastly, the stability criteria, which are the same intact stability criteria used in the NAPA loading computer. Now I will show some examples of how the vulnerability level can change due to the opening and closing of watertight doors. In each example, the ship's navigational mode is at sea and stability criteria are met. In the first example, two watertight doors are open on the same transverse bulkhead, so there are two affected compartments. This corresponds with a yellow vulnerability level. The second example again has two watertight doors open, this time on adjacent bulkheads. In this case, three compartments are affected, yielding a yellow vulnerability level. Note that if the navigational mode were sea with risk, the level would already be red in this case. In the third example, 2 watertight doors are open on non-adjacent bulkheads, so 4 compartments are affected, causing a red vulnerability level. In all 3 examples, the vulnerability level tells the officers on board at a glance that the ship is at medium or high risk in the case of damage. Now, what happens when damage occurs? In the fully automated system, there are 2 flooding level sensors per compartment. Water is detected, and an alarm is immediately triggered in the NAPA Emergency Computer. Using the rate of increase of flooding levels and the difference in flooding levels, the software calculates the breach size and location of the damage. Next, a time domain prediction will start, which could take 2 to 5 minutes. Once the first prediction is complete, the survivability level is estimated and presented according to vessel triage color coding. The prediction will then run continuously, taking into account the latest data from automation, including closed doors and tank levels. The survivability level is opposite to the vulnerability level. A high survivability level indicates the ship is more likely to survive, while a low level shows the ship is less likely to survive. For a high green level, there is limited flooding, the ship is stable, and orderly evacuation can be done. A yellow level indicates that there is extensive flooding and possibly large heel, but orderly evacuation can still be done. A low red level means there is very extensive flooding, progressive flooding to multiple watertight compartments, and very large angles of heel. At this point, orderly evacuation may not be possible, suggesting that external help should be requested. Remember, the NAPA Emergency Computer is a decision support tool for the master of the vessel. The software does not present specific conclusions, rather it provides accurate predictions, which help to assist the master in deciding how to handle the situation. Now that you understand the key concepts, I will begin the NAPA Emergency Computer demonstration. When you first open the NAPA Emergency Computer, you can see the status page, which shows key information at a glance in the upper left-hand corner. As the vessel is intact, the vulnerability level is shown. At the moment, the level is green because all watertight doors are closed and stability is okay. Additionally, current draft, heel, and trim data are shown at all times. The first thing I would like to demonstrate is the effect of watertight doors on the vulnerability level, as I described in my previous examples. Currently, all watertight doors are green, which means they are closed. In the case of one compartment damage, only one compartment would flood, and thus the vulnerability level is green. Now I will set one watertight door to manual open by clicking on the door and selecting the corresponding option. The vulnerability level has changed to yellow, since now 2 compartments could be flooded from a 1-compartment breach. Note that the software has no effect on the physical watertight door. I changed the status of the door within the software only for the purpose of demonstration. However, this could be used in a real damage scenario if, for example, there is a known issue with a particular door sensor. Now I will simulate another open watertight door. As the door I have selected is on the same transverse bulkhead as the first door, the vulnerability level will not change, because still only 2 compartments are prone to flooding. However, if I open a different door on a non-adjacent transverse bulkhead, the vulnerability level will change to red, as now 4 compartments are prone to flooding. To set the door statuses back to automatic, meaning they will use the status provided by ship automation systems, I will click the Tools button on the right and choose Set All Watertight Doors to Auto. Now you can see there are 5 open doors. This number is referring to the watertight doors only, as only watertight doors affect the vulnerability level. The door statuses update in real time since NAPA receives data from ship automation systems. The doors which are currently open are listed in the active alarms list on the bottom left, which correspond to the red watertight doors shown in the deck plans. Remember, green watertight doors are closed doors. You might have noticed the vulnerability level is still green. This is because a 30-second window is given for crew members to pass through the door, and the vulnerability level should change to red shortly. Now water has been detected by flood level sensors. Without any user interaction, an alarm is automatically triggered in the NAPA Emergency Computer, and the affected compartments are indicated by flooding alarms in both the deck plans and the active alarms list. Currently, the software is calculating the location and size of the breach. Now we can see the possible damage locations in the deck plans. You should also note that in the active alarm list, flood volume and rate of flooding are displayed for each affected compartment, and the upper left status section shows the number of flooded compartments and total flood volume for quick information at a glance. We can see the first prediction has begun. I will switch over to the Prediction tab, and we can see the dynamic flooding advisory cards have begun to populate. For example, in about 10 minutes from now, heel exceeds 10 degrees, and at this point, evacuation may be extremely difficult. Clicking on the flooding advisory card will display the predicted progressive flooding in the deck plans, as well as the predicted status in the upper left corner. Note that the prediction is still in progress, as indicated in the progress bar at the bottom of the screen. As the prediction continues, more flooding advisory cards will populate until the vessel reaches equilibrium, capsizes, or times out at 3.5 hours from now. Until the first prediction is completed, the survivability level will be at its lowest point, and then the level will be updated with the predicted survivability. However, this simulation has 8 flooded compartments, so I expect the survivability level will not increase once the first prediction is complete. Other notable events are also highlighted in the flooding advisory cards, such as bulkhead deck flooded. Also note that once the heel angle exceeds 15 degrees, the card turns red, indicating that it might be impossible at that point to evacuate passengers or lower lifeboats. However, until the prediction is complete, it is possible that the vessel will reach equilibrium at a smaller heel angle. I believe the first prediction is almost complete. Now we can see the ship will capsize in 2.5 to 3 hours from now. As expected, the survivability level is very low since the vessel is predicted to capsize. At this point, the master should most likely request immediate external help, and the vessel should be evacuated, if possible. Remember, the first prediction takes into account the initial conditions, which in this case there were 6 watertight doors open. It is possible that the second or third prediction might have an outcome with a higher survivability level if quick actions are taken to minimize progressive flooding, such as closing all watertight doors. Now I have returned to the status page and will load a simulation for a different damage scenario. In this case, only 1 watertight door is open and 1 compartment is initially damaged. While the software is calculating the breach location and size of the breach, I would like to show the target feature. By clicking on the target in the active alarms list, the deck plan will zoom into the location of the respective alarm in case you need help finding an active alarm. In this case, I selected a watertight door. Additionally, while we wait for the prediction, I will show you the History tab, which displays information from the past 12 hours, including vulnerability or survivability status, ship floating position, a list of watertight doors which were open, and a list of flooded compartments if applicable. Now let's take a look at the prediction which is currently available to us. So far, only 2 flooding cards are available, both with very small heel angles. The first prediction is currently 13% complete. Now the first prediction has completed, and we can see the ship will reach stable equilibrium at 0.02 degrees port in about 30 to 40 minutes from now. Note that the survivability level updated to yellow as there are 2 flooded compartments. This damage scenario resulted in a fairly high survivability level, and most likely there can be safe and orderly evacuation. Thank you for your attention. I will now pass the presentation to Madalina, who will present the decision support system.
Thank you, Alex. Just one moment. So today I will talk you a little bit about NAPA Decision Support System. This is a user-friendly application which allows the officers on board to have a clear and structured set of actions that should be performed in case of different incidents. For example, in case of flooding, we will have information on which doors need to be closed, how to do that, location of the systems on board, and so on. The actions are linked to the watertight compartments, and this makes the selection of a damaged compartment very easy. The information is based on the existing documents. For example, in case of flooding assessment plan, we will use the damage control plan and damage control manual. And also, we will have pictures of the rear systems on board, like watertight doors, hatches, different valves, different systems which are used in the flooding prevention. After the completion of each plan, we will have a report which is generated, which shows which actions were performed and which actions were not necessary for that flooding assessment. We will have the timestamp when the action was done, and also the remark field. NAPA Decision Support can also be used in the daily operations checklists, like arrival, departure, pre-arrival, and different other kind of checklists. And also the plans created can be linked to the NAPA logbook. The structure of NAPA Decision Support is divided into 2 components. The first one is the editor, where the user can create the emergency plans and the checklist. And the second component is NAPA Decision Support Viewer, where the user can only see and go through the created plans, generate reports, add remarks to the actions, and the content cannot be edited. Now I will show you a short demonstration on a flooding assessment plan. So here we have the main window on NAPA Decision Support Viewer. You'll have here a list of all the plans created for that particular ship. So when you go through a plan, you just select the plan created. So in this case, the plan created is named flooding. And here we have the default view of the NAPA Decision Support Viewer, where we have in the upper part the steps, which is a simple way to bring together similar tasks. In the left part, we have a list of tasks that the crew member should go through. This is something that needs to be done and is created. This is available when the type of the plan is an emergency one, and also the tasks can be associated with the watertight compartments. In the lower part, we have the ship profile view along with the watertight compartments, where the user can filter and select the damaged compartments. And here in the right part, we have the solution for which is an answer to a task. So a task can have multiple solutions. In this case, in order to prevent for the flooding to go through the whole ship, we will go through several steps. For example, the first one is closing the watertight doors. So the officer which is in charge of doing that should do it by using the master mode switch, where you should turn the switch doors closed. This switch is located on the bridge, or use the safety management system, which again, he can choose the general closing of the watertight doors. After we perform this action, we press done, And we go to the next task, which is to check if watertight door 202 is closed. We can check it from the electronic panel and see the signal of the door. In this case, the signal is red, so it means that the door was not closed. So we press fail after we check. And we go to the second solution, which is to go to the emergency station, which is located on deck 4, on center line at frame -2. Here is the location on the GA. And the crew member should move the lever back and forth until the door is closed. He can check that from the electronic panel. So let's say that this solution worked and the door is closed. We press done. And we go to the next task, which is to close watertight door 203. From the electronic panel, we can see that the door is already closed because the signal is green. So we don't need to do anything else on it. We just press done. Then the final task in this step is to check if watertight door 204 is closed. Again, from the electronic panel, we can see that is not. The signal is red. So we press fail, and it goes to the second solution, which is to close it from the emergency station. Let's assume that this solution doesn't work, so the door is still open, so we press fail. And the final solution for this task is to go locally and close the door. Here is the location on the GA. The door is located on deck 2 on the port side at frame 71. The crew member should close the door by using the power operation lever, or if this fails, then we can use the hand pump for the local emergency maneuver. After this door is closed, we press done, and we finished the first step. Then the second step is to go and close all the semi-watertight doors from the bridge. Again, we can use the master mode switch. The crew member should switch the should switch it to doors closed. After we do that, we press done, and we check the doors if they are closed or not. The first one to be checked is a door semi-watertight 402. We can see it from the electronic panel that it's closed. The signal is green, so we press done. After that, we check the door 403. This one is open because the signal is red. So we press fail. And we proceed to the second solution, which is to close it from the emergency station number 2, which is located on deck 4, port side frame 234, and here is the location on the GA. And again, the officer or the crew member should move the lever back and forth until the door is closed. After we perform this action and indeed the door is closed, we press done, and we go to the next step, which is to check if the side doors and the moving platforms are closed. We have here a list of those systems which are installed on board, along with their description, their location, and their name. And also we can check the signals from the safety system management. And we can see here that some doors, let's say, are not closed. Their signal is red. So we press fail on this step. And we go to the next solution, which is to close the side doors locally. So the crew member should proceed and close each door by using the closing mechanism of them. After we close them, we press done. And the final step in containing the flooding, in this case, is to close the hatches. Here is a list of the hatch covers which need to be closed, the operation mode for each one, and the location and their name. And also we have the rear picture of the hatch for an easier identification. As I said, we can add remarks. So for example, in this case, let's say that the hatch was not closed. So we press fail. The report will be generated. The report looks like this. You will have a list of actions. You have green check marks for those where the user pressed done, and red X's where the action failed. Also, you have the date when the action was performed, and also the remarks here. This report can be printed or can be saved on the local computer. I mentioned that the user can select the damage compartments. So, for example, let's say that the damage compartments are 2 and 3. You can already see here that you will have fewer tasks than before, because those tasks are associated with the watertight compartments when the plans are created. Also, you will have here under each plan, you will have the reports tab here, where the user can see all the reports created for that particular plan and the date. So this is NAPA decision support. If you have any questions, please write them in chat, and we will go through them on the Q&A session. Thank you. I will pass now the mic to Jussi.
Thank you, Madalina. And thank you also, Alex, for these presentations. Now, if you there is a few questions already. If you have more questions, so please don't hesitate to type them in the chat board there. So we will be handling those. Just a few words still about the NAPA Emergency Computer. So, as it was mentioned by Alex, so the system as itself should really never be used as a single source of information when making decisions in an emergency. NAPA Emergency Computer is a decision support. It is not a decision making. It will not control any kind of system. And of course, it's always good to fetch the information from all sources when making the decisions. And also, as mentioned, so the emergency computer system relies on other solutions on board, such as the signals about the watertight doors or the signals from the flooding sensors. So, of course, if there is any failure with those systems, so the usability and the accuracy of NAPA Emergency Computer cannot be guaranteed. But basically what we saw today is that NAPA Emergency Computer can be used as a decision support tool for flooding emergency situations and for minimizing their effects, so to take the right countermeasures. For that, so in the emergency computer itself, there is 3 main functions. First of all, the vulnerability, telling you about the or giving you the safety awareness level on board the intact ship. And this is a module which you can use on the everyday operations. Then the damage extent monitoring in the survivability assessment, which is used in the flooding emergency situation, which starts automatically when there is water detected on board by the flooding sensors. And then last but not least, the decision support advisory cards, which will help you in for the countermeasures. Now let's go on a little bit to the questions, and I'm looking at the chat board here. So the first one, which is probably not a question but more sort of comment about probabilistic stability, which is rather complicated because it's not taught nautical schools or colleges, and that there is no IMO or NI published book yet on the market. So probabilistic stability is, of course, something that we are also aware at NAPA, and this is something that we follow. And I think this is quite a good hint for us as well, that because we have a lot of expertise here at NAPA, so we should probably plan also some kind of well, let's not say full training, but at least some kind of information webinar on probabilistic stability. Then the next question I have here, and this is probably something that I could give for you, Alex, to answer. The question is that what is the relationship between NAPA Emergency Computer and then the NAPA Loading Computer? So how are they connected between each other?
So the NAPA Loading Computer and NAPA Emergency Computer are both, they're using the same exact NAPA model, which is a 3D model. They're taking the same automation signals, for example, tank levels. The loading computer is a static, it provides static information. It's not time-based, while the NAPA emergency computer provides the time domain flooding predictions. If you've used the loading computer before, you know that there's the damage task where you can predict, you can make flooding predictions, but those are based on different stages of flooding based on percentage volume flooding. And again, while the NAPA emergency computer is based on time.
Thank you. And I think the second question will go to you as well, Alex. It said here that on my ship, the emergency computer was working in a way that we had to specify the breach. Is it small, medium, or large breach? And consequently, the prediction was calculated. So probably if you could go back a little bit, or because this looks that the ship is working so that there is only the manual way of predicting the flooding. So could you explain a little bit more about this case? So obviously here there was no connection to the floating sensors, which would, in a normal situation, give the information to emergency computer.
Just to add here, again, as Jussi mentioned, the system is heavily reliant on the interfacing with automation systems. So if there's an issue with the interface, with, for example, the ship automation system, the main ship automation system, we would need to look into that and verify that NAPA is receiving all of the correct data. But then Jussi also mentioned already the case where manual damage needs to be defined, and this would be if on board there are not 2 flooding sensors per compartment, in which case the user needs to manually define the location of the breach. But you could please reach out to us after this webinar, and we can take a more specific look into all of the data that you're receiving and why you might need to manually define the damage.
Okay, then Alex, please stay still here, because the next question is also something where you might answer. So what will happen when or if we lose the signal from one of the sensors? So does NAPA then calculate assumed on the heel and trim, or what would happen there?
So in the case that there is lost either tank level data or flooding sensor data, well, with regards to the flooding sensors, you can manually define the the breach location and breach size, so the software can decide the correct rate of flooding there would be. But for the tank levels, if for example there's an issue with the tank level sensor, you can actually override the level being used in the NAPA Emergency Computer by entering it manually in the NAPA loading computer with the option of sensor broken for the status of that particular tank. If you would like more details on how to set the tank levels manually, I'd be happy to send you that in an email afterward.
Then I have a question for Madalina. How are these decision support plans done? Is it something that the officers on board can do, or can they update them?
The content can be done by the officers on board, yes, and they can update the already created content by the technical consultants at NAPA. Basically, the information is taken from the damage control booklet and damage control plan, as I mentioned. So, yeah, if they have updates on the systems, they for sure can update the content.
Thank you, Madalina. Then I have a question, probably Alex, you know more about this, and this might be related to NAPA loading computer. But the question goes, is it usual that the actual manual tank readings cannot be entered into NAPA computer during emergency tank checks? We always have to hand transfer it by tank diagram into tons.
Typically with the NAPA loading computer, everything would be fully automatic. If there is a link with tank level gauging system or ship automation, where you would select the update tanks option in the loading computer, and all of the tanks which have level sensors would update automatically.
Okay.
Just reading your question. You enter the levels during emergency tank checks. I'm not exactly sure what you mean by that, but perhaps you could reach out to us separately, and I can help you with the specific issue as well.
Then we have a question about the about if the flooding sensors reach NAPA loading computer, so will it also reach NAPA emergency computer? So does the information, the flooding information, come from the same source to NAPA?
Yes, the loading computer and emergency computer both pull from the same information that we're receiving from automation systems.
Thank you. So I think we have gone through the questions, and if you have more questions, so please feel free to contact us. You can contact me directly at jussi.siltanen@napa.fi, or then our sales at napa.fi address. So we will then be addressing your question to the right people. Now the webinar has been recorded, and we will be then putting the link about the recording later this week. So if you want to share that with, for example, your colleagues, so you can do that. In the end of this webinar, there is one question about what you would like NAPA to address in future webinars. I would just like to advertise a little bit that during the full-time or rest of the year, so we will be having at least a webinar on more about tips and tricks of NAPA loading computer, and then we will be having also one webinar regarding NAPA logbook. So there is a lot going on around electronic logbooks currently, especially now that MARPOL information can also be recorded electronically. So please follow our channels on LinkedIn, on Twitter, and we will be also advertising these in our newsletters. But I would like to thank you, first of all, very much, Alex and Madalina, for presenting us NAPA Emergency Computer, and to thank the audience today. It was very nice to address to you and to present you the NAPA Emergency Computer. Thank you very much for your attention. Goodbye.